So we're going to use this in a combination of a couple of triangles to be able to determine some precise sine, cos, and tan values. But let's begin by actually looking at what the unit circle is. Well, it's a circle, and the radius is a unit. So it's a radius 1 circle on this axis. Okay, so if we have a nice sketch of that. Now, importantly with the unit circle, I really do that you sketch it at the start of your exam, like maybe on the front page of your exam booklet or on a piece of rough paper that you keep with you, because this will make it so much easier. Now, let's say we pick a point here. So the whole thing about the unit circle is we pick an angle and we join up the center to that angle, okay? And we measure the angle from the positive x-axis. So this is going around as positive theta, and going the opposite way clockwise is negative theta. So now theta is then this angle here that we measure. Now what I can do is I can then also label on the vertical and the horizontal side. So if I draw down here, we've got its vertical side, which is basically its y value. And then I've got the horizontal side of this triangle, which is basically its x value. Okay, so I'm going to label these as the x and the y coordinate on this unit circle. Now, because I know the radius of this circle is 1 and know the hypotenuse is 1, I also know that I've got a right-angled triangle because I've got a horizontal and a vertical, which we know are perpendicular. So I can use SOHCAHTOA. Now, SOHCAHTOA says that sine of theta is equal to the opposite side over the hypotenuse side, which is y over 1. So the y value is equal to the sine. So I can see here then that well, I reach a maximum of y equals 1, so, and then a minimum of y equals minus 1. And then there's going to be points when it's equal to 0. Now, importantly, we're going to look at when things are positive and negative. Now, if sine is represented by y, then it means that everything above the x-axis is going to have a positive sine value for that angle. So we see here that sine is positive here, and sine is positive here. Using a similar thought process, cos theta is the adjacent over the hypotenuse, so it's going to equal the x values. So that means then that everything to the right of the y-axis is a positive cos, so cos is positive here and in this quadrant here. And finally, tan is the opposite over the adjacent side, which is equal to y over x, which we know as well is the gradient. So we look at when the gradient joining the point on the circle to the center is positive, and that's going to be again in this quadrant and in this bottom left quadrant. So if I take all of this and summarize the information together, what I can see then are the regions when each trig function is going to be positive, and obviously if it's not positive, it must be negative. So we say all are positive in the first quadrant, so that's a capital A. Sine is positive in the left. Tan is positive in the bottom left, and then cos is positive in the bottom right. So some people remember this as the caster diagram. I actually begin with the A because that reminds me that I start measuring my angle here on the A quadrant. So I always remembered, well, we live by a shop called Asda. So we said Asda sells tasty chicken. But you could say all students to Cambridge, all stations to Calcutta, anything that's going to help you remember this order. Okay, so this means that if I know which quadrant it lies in, I can tell if it's positive or negative. Okay, so the unit circle identifies where each trig function is positive and negative. Now we can also use a couple more equations here. So if we look at tan, Well, we said that tan theta was equal to y over x, but we also got other equations for both y and x. So substituting those in, we get the equation that tan theta is sine theta over cos theta, which is one of the identities in the data booklet. Now if we use Pythagoras on our triangle, we see that x squared plus y squared equals 1 squared, which is 1. And putting in sine and cos, we get sine squared theta plus cos squared theta equals 1, which is another formula that is in our data booklet. Okay, so going into the exam, remember this diagram here. Okay, now let's think about the specific values that you need to know. So you need to be able to work out, say 0, I'm going to use radians for this to get a bit more practice. Not for me, for you. Pi over 2, pi, 3 pi over 2, 2 pi, etc. And these we're going to do when we look at the graphs. So use graphs to remember. We also need to know pi over 6, pi over 4, and pi over 3, and variants of these. Now, I think the best way to remember this, if you remember a list of values, I don't think, that's fine, but I don't think it's very efficient. And I think that you can spend your time focusing on remembering other things. Now, what I would remember is 2 triangles. So first of all, if I draw an equilateral triangle, say here, let's make it a big one, but I'm going to split it down the middle as well. Okay. Like so. Now if I make each length of the triangle 2, because I've split this side down the middle, it's going to be 1. And using Pythagoras, this is going to be square root 3. Now, an equilateral triangle has 60 degrees at every angle, so this is my pi by 3. And because I've split this down the middle, this will be my pi by 6. So I can use this triangle with SOHCAHTOA to find specific values, okay? So for example, sine of pi by 6 is equal to the opposite side, 1, over the hypotenuse side, 2. Tan of pi by 3 is equal to the opposite side, root 3, over the adjacent side, 1. Okay? So it's really easy once you've remembered this triangle. And again, I would draw this on your on the front of your paper. Now, some people say, oh, well, you just need to learn the sine values and you can get everything else. Well, yes, but then it takes you a bit of thought process to get to the other cos and tan values. Whereas if you've got this sketched on your on the front of your exam paper, then it's really, really easy to just come back to it. Okay, so what I'm going to do is I'll just rub out this half. So I call this my 1, 2, root 3 triangle. Now we can also use our 1, 1, root 2 triangle. Okay, so I'll make it sort of look like that. So it's a similar sort of thing, apart from we are now dealing with a triangle which is actually an isosceles triangle instead of an equilateral triangle. Now we need 45 degrees, and because I know that this is a right angle in the bottom right, then these two must be the same length to make these angles both 45 or pi by 4. Now keeping our numbers simple, if I make both of these length 1, this length will be root 2, so I can use this triangle as well in the same way that I did to the left. So this is my 1, 1, root 2 triangle. Okay. Now let's very quickly look at how we combine this before I see if there's any questions in the comments, okay? Because that marks sort of like the end of the first part. So, now let's say I want cos of Let's go back to degrees for a bit, 210 degrees. Okay, so for anything like this, which is a mixture of, say, 30, 45, or 60, and some other number, we're going to use the unit circle and the triangle. Okay, so the first thing we're going to do is we're going to sketch the angle on the unit circle. And once we've done that, we'll identify the acute angle between the x-axis and the line I've drawn. So if you look to the right of this thing, I'm going to draw another unit circle. So 210 degrees, well, it's positive, so I know that I go around anti-clockwise. This is 90, this is 180, so that's about 210. I draw my line now, connecting it. And importantly, I label the acute angle between the x-axis and the line. So that's this angle here. Okay, so this is the angle that I care about. The 180, doesn't really matter. But this angle then is going to be 30 degrees. Okay, so I know that I'm looking at the 30-degree angle in my triangles. Now looking at my cast labeling, I know that in this quadrant, tan is positive, everything else is negative. So what we do is we relate the 210 degrees to the 30 degrees using the sign. So what I'd say here is that cosine of 210 is equal to negative cosine of 30. Okay, so it's the same value because we're looking at the x value. Okay, well, the x value, if I drew 30 degrees here, if I drew 30 degrees in this direction, on the unit circle, it's the same x value, but on the left it's negative and on the right it's positive. So that's how this method is going to work. It uses the symmetry of this unit circle to say that it's the same number, just with now a different sign. And then finally, step 3, we use the triangles to find cos 30. So cos 30 is equal to root 3 over 2. So this is minus root 3 over 2. Okay?
I hope you enjoyed the video. If you did, be sure to click down here to like, subscribe, and share with a friend. If you'd like to access the full online course, including the notes pages we were making, there's a link in our description below. Thank you for watching and good luck with your revision.